Okay, here are some things that we've been already kind of using or thinking about, and you guys used it a ton last year, so it should go pretty quick. Increasing, decreasing test is a huge test that you use in calculus. So it's saying if the derivative is greater than 0, that means the slope's greater than 0, so the graph is increasing. So that's all that piece is. Less than 0, it means it's decreasing. And then concavity, if the second derivative is greater than 0, then it's concave up. If the second derivative is less than 0, then you're talking concave down. Oh, they can't hear us. Oh. Okay, so first derivative, increasing, decreasing. Second derivative, concavity. If you look at the picture here, I drew a nice picture of concave up. It's curved up, concave down, curved down. It's an inflection point in between, so that's what this says here when it changes concavity. Okay, so first derivative test, if the derivative changes from positive to negative, that means your function is going up and then going down. Then there has to be a local max at that spot. If it changes from negative to positive, that means it's decreasing then increasing, so there has to be a local min at that spot. And if c is a critical number and the derivative does not change sign, then there's no local max or local min. So it might look something like this, where it flattens and then goes up again. Okay, so if it doesn't actually change sign, if it's increasing the entire time or decreasing the entire time, it just flattens out for a second and then goes back up. So there's no max or min there. Okay, second derivative test. Second derivative test gets forgotten a lot because a lot of people just don't use it. I know on the AP Calc BC test, I want to say maybe 3 years ago, they had a question where it was like, oh, we can't solve this, and we thought and thought and thought about how to solve it, and the second derivative test was the only way we could come up with to actually solve the problem. So sometimes it is necessary, and sometimes they write questions where you have to use it. It's not a difficult test, it's just not used that often with people because you usually use a different method. But second derivative test says the second derivative is continuous if the first derivative is 0 and the second derivative is greater than 0. So this is telling you that it has a horizontal tangent, and this is telling you what? That it's concave. When the second derivative is greater than 0, it's concave up. So if it has a horizontal tangent and it's concave up, you're going to have something that looks like this-ish. So at this spot, there has to be a minimum. Okay, same idea if you have that there's a horizontal tangent and you know that it's concave down, then you know that there has to be a maximum at that spot. And in our regular calc class, we use that often because the book kind of writes questions for that. A lot of times in AP Calc, I know people don't use it as often because you use a different method, but it is valuable for problems, and every once in a while you actually need to use it to solve problems. Okay, we're going to do page 220, number 8, so get your books out. And number 7, I think, is part of your homework. I did the opposite one for the A, B, and BC class. That way you guys can check your answers for 7 when you do your homework. Okay, so number 8 looks like that in your book. And this is, these questions, sometimes people overthink them a little bit. They're not necessarily difficult if you really think about like the first derivative test and the second derivative test, but it's very easy to confuse yourself because sometimes when people see that something's greater than 0, they're thinking that it's increasing. Greater than 0 means positive and those type of things. So we'll work through this one, and if you have questions as we go, that's completely fine. So number 8, the first part, so the graph's on the right-hand side on page 221. That's the graph that's here. And number 8 says the graph of the first derivative of a function is shown. So make sure you're looking at this graph. On what intervals is f increasing. So what graph am I looking at here? I'm looking at f prime, and that's really important to think about, okay? So if I'm looking at f prime, it's telling me what? It's your slopes, right? So think back to the first derivative test. When the first derivative is greater than 0, what do I know? It's increasing. Yep. And when the first derivative is less than 0, f is decreasing, okay? So write that on your paper because it actually helps you answer the question correctly rather than, getting something confused here. So it says, on what intervals is f increasing? So we're not talking about this function. We're talking about actual f. So f increases when the graph we have is greater than 0. So wouldn't that be from here to here? So from here to here we have increasing. And then, yeah, over here from 6, and you could say to infinity, or you could say up till 9, because that's where the graph goes. Either way, you'd be fine on your AP test. Okay, so let's start answering part A. Increasing when, and I always write y, because justifying your answer gets you a point, typically on the AP test. So when the first derivative is greater than 0, and then we go ahead and we answer when that is. So from 2 to 4, and then from 6 to infinity, or 6 to 9 would be fine as well. And explain, so we explained it by saying it's when the first derivative is greater than 0. And it doesn't even ask about decreasing, but decreasing would obviously be the other spots there. Any questions on the increasing? Okay, so on part B, A and B go hand in hand here. Part B is asking about the maxes and mins of the function, the f function. So when you're talking about the f function here, it's decreasing here, it's increasing there, it's decreasing here, and it's increasing there. So the function is decreasing, then increasing. So what is this spot right here? If it decreases, then increases, this would be where there would be a min in between those. Okay, and not an absolute min, so you want to write local or relative there. If you just write min, you're saying it's the very lowest point, so you're calling it an absolute min. So make sure you write the word local or relative there. And if it changes from increasing to decreasing at this spot's going to give you a local max. And then decreasing to increasing again, so here we've got our local min. And then it increases after that, so we don't have any more. So for part B, at what values of x does our function have a local maximum or minimum? So local maximum when, you could say when the derivative changes from what to what? Local maximum. Okay, so yep, you have to be careful about how you word this. So it's a local maximum when the derivative changes from positive to negative, or when the function changes from increasing to decreasing. Okay, and a lot of people mix those up, how they word that. So it's up to you. I'm going to say local maximum when f prime of x changes, because that's what I'm given the graph of. But it's up to you which way you want to go with that, from positive to negative. And then list it here. So that would be when x is, local max was at 4. Okay, and then wouldn't you do the same thing for local min? Okay, so because we're getting through notes quickly, we'll just write it quick. Local min, same idea, you'd write the same thing at x equals 2 and x equals 6, it looks like. Okay, so I'm going to give you a minute here to think about part C, and then part D goes hand in hand with part C. So go ahead and think about part C before we go through it together. Remember, this is the graph of the derivative. How are we doing on part C? So part C is talking about concave upward. So the first thing I want to write is something like this line here. It's concave upward when what? So it's concave up when, more basic, the second derivative is greater than 0, right? So I always write that line first because that usually gets me my justification points even if I mess up my intervals here. Okay, so that's talking about when your f prime has positive slopes, right? So the slopes of f prime are greater than 0 because slopes is derivative. So the derivative of the derivative would give you the second derivative. So when are the slopes of my graph here greater than 0? 1 to 3 would be the first spot, right? You see how the slopes are positive? So from 1 to 3, where else? 5 to 7, and so 5 to 7, then 8 to 9, or 8 to infinity. It's up to you there. So questions on that one? Okay, then part D. D says, what are the x-coordinates of the inflection points? So the inflection points would actually be like our local maxes and mins of the graph up here, right? So when it changes from decreasing to increasing, because that's when the second derivative is changing. So it would be at this spot, here, here, and here. So we've got 5 of them. So 1, 3, 5, 7, and 8. Does that look okay? Questions at all on that? Okay, so the AP test, they really like to switch it up. Sometimes they give you the graph of the original function, sometimes they give you the graph of the derivative, and sometimes they give you the graph of the second derivative, and then they expect you to like pull different values off of that. So I think 7's in your homework. If it's not, you should do it anyway. But it's changing the graph that's given there from being the regular function to being the derivative function to being the second derivative function, and asking you different questions. It's asking when the inflection points occur, so you really have to understand all those pieces, which is good. Okay, so next here, page 331, I have the problem up on the board. And the question is, find when it's increasing and decreasing, find the maxes and mins, intervals of concavity and inflection points, and then you'd sketch a graph there. Now on the AP test, the first 3 of those are, they show up a lot. Actually sketching the graph doesn't show up that much, and we're going to do a curve sketching one here later on. So we can skip the curve sketching part of it for now. But let's start here, find the intervals of increase or decrease. So I always write here it's increasing when what? F prime is greater than 0. And then I'll just write my decreasing. That way I get my justification points without even having to do much work here. Okay, and then we actually have to find the derivative, so that's pretty easy here. So we get 4x minus 4x cubed. And I'm going to find when it's 0. So what's the easiest way to find when that's equal to 0? Take out a 4x. Okay, do not just move one of them to the other side and divide by an x, because then you're getting rid of one of your answers. Okay, if you cancel an x out, you're actually getting rid of an answer there. So take a 4x out. If you can factor, it's always good. This turns into 1 minus x squared. Okay, and then you set each of these to 0. So if I set this to 0, I get x is 0. If I set this to 0, what do I get? Plus or minus 1. And we want the intervals of increase or decrease. Do you guys, are you guys familiar with the whole number line thing? Yeah, it's how most people teach it. So what you have to write if you're using the number line thing on the AP test is you have to put that this is f prime. We're going to put where our zeros are for my derivative, which are negative 1, 0, and 1. Okay, so at these spots at 0, if we go, let's start with positives, between 0 and 1, I always try to plug into here rather than plugging into here because it's easier. So if I plug a half into here, is this positive or negative out front? Positive. And inside here, if I plug in a half, it's going to be positive. So this part's positive. What does that mean about my function? It's increasing. I just always write it like this so it's easier for me to actually see what's going on. If I plug in something bigger than 1, so like a million, we get positive and negative. So it should be decreasing. Okay, if we plug in a negative, a half, we would get a negative out front, and this would be positive. And then you plug in a negative value that's, you know, larger than, or I guess less than negative 1, larger than negative 1, negative. So you would get a negative out front and negative. So yeah, exactly. So then we get a positive there. Okay, and then answer the question. So it's increasing. And we're increasing from negative infinity to negative 1, and then from 0 to 1, and then decreasing from negative 1 to 0, and then from 1 to infinity. Now, they've told me at those AP conferences that just having this here is not enough. Okay, the number line thing is not enough to justify it. That's why I always have kids write this part down. Okay, practice writing that part down in your homework, even though it's like, oh yeah, I'll remember to write it on the AP test. If you don't practice it, you're not going to remember to write it then. Okay. Okay, so that's part A. Part B, find the local max and min values. So this is the part that goes with that. If it switches from increasing to decreasing, this is going to be a local max. This one here, decreasing to increasing, local min, increasing to decreasing. So for part B, find the local max and min values. Now this is where people get points wrong because they say it's at x equals negative 1. So these are my maxes, and x equals 1. What am I doing wrong here? Yeah, it's asking for the values. So it's actually asking for what the max and min y values are. So how would I find the y values? Yeah, so plug them back into the function and find what the values are. So the local maxes occur at these spots, and then a local max value is going to be, and write what it is. So I'm going to write my stuff a little better here while you guys plug those in and do the work for me. So what do we get when we plug 1 in? 3 sounds good. And what do we get when we plug negative 1 in? Same thing, right? Because isn't it all even? Okay, so those are your local max values. Same idea for local min. So local min is at x equals 0, we said there. And when you plug 0 in, you get a value of 2. So questions on that at all? Okay, then part C is talking about the intervals of concavity and inflection points. So if I want to do that, first I'm going to write that it's concave up when what? Yeah, when you have your f double prime is greater than 0, and then the concave down, I'm getting my easy justification points here. If this is a free response question, you need to get all 9 points on this, okay? These are very straightforward questions when they put them on there. Okay, so then we need to find what our f double prime is. So use your function, your first derivative from above, and I'm getting 4 minus 12x squared. And then you do the same idea where you're doing your finding where that's 0, doing your number line, finding the positives and negatives. So let's do that. Okay, and I'm going to take a 4 out, but you wouldn't have to. And this can't be 0. You could just divide by 4. It goes away. So to get this equal to 0, you'd add the 3x squared over. And then divide by 3. So what is my x going to be? Yeah, it'd be plus or minus 1 over square root of 3. Just leave it like that. Okay, and you don't need your calculator, even though you might think you do. Sorry, my slate stopped working here for a second. So go ahead and set up your number line. Okay, so we're plugging into the second derivative, and then we're going to find out what that tells me about the function. So if I plug 0 into the second derivative, I would get positive, right? So what does that mean about the function? Concave up. Okay, if I plug in something bigger than 1 over square root of 3, don't overthink it. Plug in a million. Okay, if you plug in a million, what do you get? Negative, and that gives you concave down. Negative a million. Same thing, right? So then to write our intervals here. So it's concave up from negative 1 over square root of 3 to positive 1 over square root of 3. And then concave down from negative infinity to negative 1 over square root of 3. And then the other side of that. And then it still asks for the inflection points. So inflection points are where? Okay, and these are just my x values, right? They're asking for the points. So we have negative 1 over square root of 3, comma, something, and 1 over square root of 3, comma, something. Okay, so we got to find what those are if you want the full points for your answer. and you're plugging back into the original. The nice thing about the original is these are squared into the fourth, so does it matter which one I'm plugging in? No, you should get the same answer for both of them. So if I plug in, let's just do the positive. Obviously we have 2 here. What's 1 over square root of 3 squared? 1/3. Okay, what's 1 over square root of 3 to the 4th? Wouldn't that be this squared? So what do we get? 1/9. Okay, and you could get a common denominator, or this is technically accurate to 3 decimal places, so you could literally write that in that spot. Okay, so 2 plus 2/3 minus 1/9. I just don't feel like, doing mental math, and that might happen to you on your AP test. I would actually do that out, but any questions on that? Now, obviously, if you have to do a sketch or something like that, you'd want to have, an idea of what those decimals are so you can actually do the sketch, but that'll be a different lesson, so we don't have to worry about it now. And this is just an explaining one. It's not anything earth-shattering here. We've got a coffee mug that looks something like this, and it says coffee is being poured. I know, don't write it down even. Okay, sketch a rough graph of the depth of the coffee as a function of time. So if you're pouring coffee into this at a constant rate, if the base is large, or ish, if the base is kind of large, does it look like it's filling up fast or slow? Slow. But what happens when it gets thin in the middle? It looks like what's happening. It's filling up really fast, and then towards the top, it's going to look like it's filling up slow again. So it kind of fills up slow, and then fast, and then slow. So the graph would look something like that. So you'd have an inflection point would occur at like the skinniest part of that mug. So those type of questions don't come up a whole lot on the AP test, but they're always good to at least have seen before in case they do. And then there's your homework you guys can start on.